So we're dealing with compound interest growth problems where the interest rate can change, where you can add multiple payments or withdrawals. And that sounds a bit intimidating. So let's just start by breaking down one question. So let's have a quick read through one question. So it says, Thabo invests 1,000 Rand in a bank for 10 years. Okay, so that is the first bit. It says the interest rate was 6.5% compounded quarterly for the first 3 years. For the next 5 years, the interest rate was calculated at 7.2% compounded monthly. And then for the remainder of the investment, the interest was given at 7.8 compounded semi-annually. Then the question is, how much money did Thabo get at the end of the investment? Now, the problem with these questions for most students is it's like, oh my goodness, there's just too much going on. And so what we really need to do is take all this writing, and I'm not sure if all my colors are helpful or they're confusing you, but what I want to suggest is a very first thing to do is get a sense of how long is the length of time involved here. And what I'm going to start with is a T0 over here. And I want in the chat or people to raise their hand, what do you think this is going to be over here? So if you imagine that's T0, later on I could maybe say like that's T1, and that's the end of the year. But how many years are involved in this particular question? Okay, T10, absolutely. So that's the end of the year. So the journey that has to happen is one that goes from 0 to 10 years. Now, at the very beginning, 1,000 Rand is invested. So what I like to do is I just put 1,000 at the bottom in line with T0, because then I know that's how much started. Now, what are the other points along the timeline where things get exciting? Like, or points at which the maths has to be changed or adapted? What are the other points along the timeline that you think might be important? So T10 and T0 are the two things, but now there's some other places along the timeline where things are important. So it says for 10 years, but the interest rate, so we look at the green one, the interest rate was 6.5% compounded quarterly. So I think that T3, now I'm not going to say too much other than T3 seems important. Now, what do you think is going to happen? What's the next point in the timeline that's going to be important? So you've kind of made use of the green one, but what about the next? Now, it's not going to be T5. You're on the right track, but the problem is it says for the next 5 years. So if you go the next 5 years, if you go T3, you're going to have to get 6. Okay, so I haven't done this perfectly in line, but essentially the next important bit is going to be T8. Now I haven't even, this is not a perfect scale, but it's just over there. And then it says for the remainder of time, something happens. Okay, so there's 3 different interest rate changes. The timeline shows that. Now, what formula are we going to use to add up the money over time? Well, we are going to use the compound growth formula. So if we go back to the previous, in fact, just give me a thumbs up if you understand why, if you've given this amount of money and it's growing at different interest rates over time, we'll be using the compound interest formula. Give me a thumbs up if you understand that. Okay. Now, the problem that we have to deal with is the interest rate is compounded differently. So for the very first bit, I'm going to use the green one, and I'm going to say this period over here needs to be, what should I say? Well, it's compounded quarterly. So all I'm going to do here is I'm going to say 0.065 divided by 4. Give me a thumbs up if you understand. So the interest rate was 6.5% compounded quarterly. Now, the normal rate is just 6.5%, but because it's quarterly, I have to divide it by 4. Now, if you're new here, we covered this in the last lesson. And so if you're unsure, if they tell you it's compounded quarterly, how we need the interest rate per quarter. And at the moment, it's 6.5% per thing. Okay, now here's the thing. We don't worry about doing any calculations yet. Let's go on to the next bit. Let's go on to the, let's make it blue. For the next 5 years, the interest rate was, what do you think the interest rate is going to be for the blue period? What do you think the interest rate is going to be for the blue period? So it says, so it's going to be 0.072, or I know some of you like to put it in a slightly different way, but it's equivalent. So it's that, but it's divided by 12. So that's going to be the interest rate that happens there. All right, now we need to know what is the interest rate for this last period here. Can you put that in the chat for me? Or you can raise your hand and just tell me over the audio chat if you think you know what it is. Let me know what you, pop your hand up or put it in the chat. So I see Tandor has said 0.078 divided by 2, and that's because it's semi-annual. Okay, so now what I want to suggest is actually all the hard work is done. So all we need to do now is use our awesome timeline to grow this 1,000. So I'm going to start with 1,000 and say it has to grow, but I'm only going to let my 1,000 grow up to the end of year 3. Now remember, in this period, the interest rate is in quarters. So this is going to be that. Now, what do we think this number is going to be? Now look at the timeline. Think about how it grows, and the interest rate is in quarters. It's not going to be 3 because the 3 stands for years. So because there are 4 quarters in each year, this thing over here is actually going to be a 12. Can you imagine there's 12 little quarters in here? Give me a thumbs up if you understand why it's a 12 and not a 3. Okay, now, if the question said, stop at that point, you could put the value that you've got here in your calculator and you would get a value. But the question doesn't stop here. It doesn't want to know how much is in the bank account after 3 years. It wants to know to T10. So what I'm going to do is I'm going to grow it a little bit more. And what's going to happen is this value over here is going to be the input. So all I'm going to do is I'm going to open up another bracket, because this bit over here acts like the P value. It acts like this value up here. And it is now going to be grown for the blue bit. Now, some students will struggle a little bit with that, but just think about this. Think about this whole block as being a value that has to be grown forward. Can you give me a thumbs up if you kind of get what I'm doing with that? Give me a thumbs down if you feel like you don't understand, because I just want to see if you understand. Like, I'm going to let it, I'm sort of playing it forward here. Okay, I'm losing some of you. So just think about this. If you wrote this, if you took your calculator now and you got a value, it's not wrong to get a value. In fact, I think somebody already has got it in the chat. In fact, I can even get it for you now. So I'll go 1,000 times 1 plus 0.065 over 4 to the power of 12. Now, the problem with that you can get, and you get like 1,213.4 and so on, is you still have, that's how much money you would have here. But it's very messy because you have to carry on growing. And so what I'm doing is I'm saying, look, you've got the amount here, this value gets grown. And I'm going to suggest that it grows according to this formula. But what do you think is going to be up here? What do you think is going to be the time thing here. Look at that. So how many years is it, and what information do we have that tells you about how much do we have to split each year into? So there's 5 years, but they're in months. So 5 times 12 will be 60. So the green stuff is growing it for the first 3 years. The blue stuff is growing all the stuff here for the next 5 years. And if I stopped at that point, I would be there on the timeline. So after 8 years, this is how much money is sitting in the account. But we are not done because we have to grow for 2 more years. And now I'm going to do the same trick. I'm going to say this value is what is sitting in the bank account. It's the P value up here. It's the value that we start with because we know how much is there. And now I need to grow. But what I need to do is I want to know, oh, wait, let me wipe that out. Let's quickly get rid of this. Oopsie daisy. Some of it's there. Okay, you get the basic idea. Oh, I just took out one of those. So I'm going to add another bracket here. And in this bracket is going to be 1 plus 0.078 over 2. What is going to be up here in the block? Okay, it's going to be 4 because it's 2 years, but it's how many half years are there? Or it's semi-annually. So how many half years are there? Are 4. Now, this is a bit of a nightmare to put into your calculator. But if you get all of this stuff, you will get the answer. But I have a trick to show you. So take out your calculator, and all I want you to do is I want you to put into your calculator this first bit. 1,000 times 1 plus that over 12, and I want you to hit equals. So when you hit equals up to that point here, just put an equals in your in the chat to tell me you've got to this point here and you've hit the equal sign. Now, what the equal sign does is it clears all the clutter on the screen. So now I want you to do is I want you to take the number on the screen and I want you to times it by the blue bit. And once you've times it by the blue bit, I want you to hit equals again. And once you've done that, I want you to tell me what have you got at that point in your calculator. So you hit equals over here, and then once you get here, you hit equals again. Now that is basically getting you to this point in the calculation. Now, you don't delete anything. You keep that value that is on your screen. And for the last bit, all you're going to do is you're going to times what's on the screen by this last bit here. And then I want you to tell me what do you get as your final A value. So you go 1,000 times the green equals, times the blue equals, times the black equals. And what that does is it stops having to type too many things at once without seeing what you're doing. And you should get 2024.64. Now, that does seem like a lot of work. And I admit, if this is the first time you're seeing this, you might be like, whoa, 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 this is not as easy as I'd hoped. But with practice, you will find it's a lot easier. Now, I know that a lot of students won't be happy yet, but let's get a quick sense. If you sort of followed what I was doing there, give me a thumbs up. If you feel lost, and it's completely fine if you do, give me a thumbs down. I just want to get a feel for how much I must do in the next example, because we're going to do another example now, but how much help I must give depends on how the feeling in class is. Be honest, it's completely fine. I'm not worried if you don't understand yet. I don't expect you to understand after just one example. Okay, so I'm going to talk you through a second example now. And I can see it's about 50-50 in the class. So what I want you to do is just by yourself, I don't want you to do any calculations. I just want you to set up a timeline with however many points you need. And then I want you to try, I want you to, this is sneaky. This has a simple intro, not sneaky, but okay, I'll come back to that one. Let's do this one from our past exam. Yeah. All I want you to do to start with is I want you to draw a timeline. And on that timeline, I want you to put numbers. And then I also want you to put interest rates. Well, let's actually start with the numbers. So draw in the numbers that you think are helpful for this timeline. And when you feel like you've done that, say done. So I just want you to make your own timeline. And then when you've done your own timeline, no actual calculations, just a basic timeline that represents the information in this question. And you can tell me done in the chat when you're done. So ask yourself, what do you think goes here? What do you think goes here? And is there any other point along the way? Okay. So really the hard part here is understanding where to put the information on the timeline. I want you to think about what do you think the interest rates are going to be where the red squiggle is, and what do you think the interest rate is going to be where the green squiggle is? Okay. If you look at my timeline, oh wait, there's one thing I forgot to put in. I should put a plus 14,000 because the 14,000 is how much money. Give me a thumbs up if you follow what I've done so far. Give me a thumbs down if you didn't follow. I think the trickiest bit is, notice how I have T1.5. T1.5 is, it says first 18 months, and 18 months is the same as a year and a half. And because my timeline is in years, I converted 18 months into a years. Okay, now, what I want to suggest is, I want you to try and use this formula to figure out how much this 14,000 is worth at the end. And it's got two parts that it has to grow. It has to grow from here and get to there. And then from there, it has to grow again and get to there. Now, I'll set you up with the first bit. Can you figure out what goes here to grow the 14,000 to the end of the 5 years? And if it has to be grown twice, basically try and get me the final answer for this. And when you feel like you've got it, you can put the answer in the chat. I'll give you some time now, because it's good not to rush with these. You want to just do them nice and slowly, building your understanding, and then it's like, boom, I know what's going on. So what is that first period's time number going to be? It's a year and a half, but I don't want it in a year and a half. I want it in 6 month periods. How many 6 month periods are there in a year and a half? I think there are going to be 3. But that only gets me to, I still need to think what goes here and what goes here. And then I want the final answer. So I'll wait for those answers to start appearing in the chat. So remember, when you go here, you go 14,000, you get that, you go equals. And then after you've got your equals, you do this bit. What do we think the time periods are going to be for the green part? I'm not in half years anymore. I'm in months. Now, how many months are there from T1.5 to T5? Well, it's 12 for each year, so that's 36, but there's a half year, so then this must be 42. And now I have to try and get what the answer is for growing. The red grows at the first bit, and then the green grows at the second bit. Why is it a power of 3? Oh, great question, Linukukle. So this is a year and a half, but because of the 2, it says semi-annually, and semi-annually is basically like saying for 6 month periods. And so here, the first 6 months maybe goes here, then the next 6 months is 1 whole year, and then the last 6 months gets you to a year and a half. So there's 3 6 month periods in a year and a half. That's why it's a 3. Now, what is our answer going to be for here? Keep those answers coming. Let's see, Bianca's got an answer coming in. How I got to 42? Can you see there? If you look at the second bit, there's 3.5 years to go from 1.5 to 5 years. But remember, in this period here, I'm dividing by 12, or I've chopped my interest rate up into a monthly interest rate. So I want to know how many months are there in 3.5 years. And in 3.5 years, there's 12 for each year, but there's also a half year, and there's 6 months and a half year. So that's how I get the 42. And you should get 20755.08, or basically it's grown from 14,000 to just over 20,000 in the 5 years since the initial deposit. And so all we're going to practice in the second half of the day is more of the stuff, and the hard work is just in setting up the timeline. And then this is just, you use your calculator, and when it gets too long, you hit equals, and then you hit times again. Give me another vote. I know I'm asking a lot today, but thumbs up if you feel like you're following, thumbs down if you feel like you are feeling a bit unsure. Okay, now if you are feeling unsure, don't be discouraged. We are going to practice this more in the second half of today. So all you have to do is make sure that you are do the brain break and that you revive yourself for the second half and we go again. Tando, I see that you have your hand up. I'll unmute you. What question do you have?
So I'm confused on the 3 and the 42 because normally how we say like since it's compounded semi-annually and then we're gonna
Yes.
say whatever times 2 because that's semi-annually, right?
Okay, we divide by 2
2.
to chop the interest rate. So we divide by 2 to chop the yearly interest rate into a half yearly interest rate.
Okay.
But now, so what this does is it makes the interest rate in half years. But if my interest rate is in half years, my time has to be in half years. And at the moment, what we're saying is how many half years or how many 6-month periods are there in 1.5 years? And if you think about it, 6 months is the first period, another 6 months is the end of year 1, and then a year and a half in, it's going to be 3 periods of 6 months.
Okay, so we don't go and times it by 2.
No, you times it by, you want this number to be how much time does it spend growing at that interest rate? And it spends 3 intervals of 6 months growing. Yeah. And then with the green one, it now changes to months. So we want to know how many months does it grow for, but there's 3.5 years. And that's why we go, well, 12 plus 12 plus 12 plus 6. That's how many months there are in 3.5 years. And that gives us the 42. Okay. Does that make a bit more sense?
A little bit.
Okay. Don't worry. We're going to practice this. We're going to practice this plenty of times.
Okay,
Let's stand up. Let's stand up and then let us do a bit of stretching because today's one is brain heavy. So let's just stand up and feel like you're touching the sky. Stand on your tippy toes. Your brain's been working hard. You need to relax. You need to give yourself the license to just breathe in, breathe out. I quite like that. Let's do that again. Let's do one more. Oh, breathing's the best. Feel nice and relaxed. Okay, let's shake out our arms. Get them nice and floppy loose, like a piece of licorice. And let's shake out your legs. You want to feel nice and relaxed. Let's roll your shoulders back. And you roll your shoulders forward. And then let's start rotating a little bit. So we just start off nice and slow, and then as your body relaxes, you'll notice that you could naturally turn more. Oh, I feel my concentration improving already, just because my body is feeling loose. Okay. And let us do a tricep stretch. In case your shoulders are feeling tight. And then the other side. Okay. And let's do some heart rate raising stuff. So we're going to do again, just do the normal one, the air skipping. And we'll do 20 in 3, 2, 1. Let's go. 2. 5 more. 1. And that's it. Oh, I can feel the tennis in my legs from today. Oh, I'm feeling a bit physically tired, but like good tired. So let's have a little mass 24 brain break. Can you make 24 using just the 4 red numbers, or can you make 24 using just the 4 blue numbers? Let me know in the chat if you can solve the math 24 problem. And pop your answer. For those who are new, Math 24 is just like a fun game we play to unwind a little bit in the middle of the lesson. and we try and make 24 using only the 4 numbers, and we have to use each one once. And so this is a 6, and that's a 7, that's a 7, that's a 4. Oh, wow, this is an easy one. 7 plus 7 plus 4 is 18 plus 6. So that's 24. Okay, the red was piece of cake. Oh, you're right. Keisha got another way of doing it. 7 minus 7 is 0. And then plus 4 times 6, which is 24. So Terevatso, Brooklyn, Keisha, many ways of doing. Xaise also got it. Oh, wow, we're almost all over that one. Balian's in there. So can we do the blue one? And that is 2, 2, 6, and 5. 2, 2, 6, and 5. Okay, so Gavazzo says, add the 6 plus the 5, and you get 11. And then times the 11 by 2 to get 22, and then add another 2 to get 24. So 11 times 2 plus 2, which is that. Yep. So Gavazzo, you have smashed it. Well done. And yeah, for those who are new to it, we'll do some more Math 24s in the next lesson. And it's just a fun little game to help us keep our brains sharp with multiplication and division. Okay, let's get back to the main point of today, which is to absolutely master timelines. Now, we're going to go to this question. There's one slight variation. So let's just have a look at what it says. It says 5,500 is invested for a period of 4 years in a savings account. For the first year, the investment grows at a simple interest rate of that. Now, I'm going to put the simple interest rate formula here just so that it's available. And then it switches to compound interest rate. So we're going to have to use both of these formulas. But initially, all I want you to do is I want you to draw up a timeline for me with all this information on it. So what do you think are the periods that are important? And are there any interest rate changes or things that are important? I want you to try and do your own timeline now. You don't have to do any calculations, but when you finish with your timeline, say done in the chat. And just try and put all the information on your timeline that you think I'm going to put on in a moment. I will put the 5,500 at the bottom just so that you all know that's the principle, the amount that I start with growing. And then how many other points are important? I'll give you some time for that. Hmm. 4 years. So I think that's T4 has to be at the end because it says for 4 years. So now what other points? I think there should be T1 because it says for the first year and then it switches. Okay, so we've done the time periods. Now there are going to be some interest rates. So I want you to think, what am I going to write here? And then I'm going to make a different color. What am I going to write for here? Now this one actually is just going to be 0.11. Let me use green. So 0.11 because it's 11% per annum or 11% per year. So there's no need to divide anything. And then for the next one, this is going to be divided by 4 because it's compounded quarterly. So what you need to try and do now is you're going to have 5,500, but this first bit is not going to use the compound interest formula. It's going to use the simple interest formula where the I is 0.11, and then the N, what's the N going to be? Maybe you can help me with this. What's the N going to be for that? It's going to be 1 because it's only growing for 1 year. Now, we're not done yet, but what we've done is we've grown to here. Tell me what money is sitting in the bank account at the end of year 1. So it's basically, what is 5,500 times 1 plus 0.11 times 1? What's sitting in the bank account at this point? I'll check for myself here. 5,500 times 1 plus. I get 6,105, but the problem is 6,105 is not the final answer. That's how much money is sitting at that point, but I need to get to the end. And what I'm going to do is I'm going to use the amount that is here as my input for the next bracket. So almost like, again, this is the P value. This is the value that is the input. It needs to grow. Now, what is the interest rate going to be here? Well, I'm back in compound interest land. And so this is going to be 0.125 divided by 4. What is going to be my power up here? What do you think that's going to be based on what you've seen so far today? There's 3 years that have to cover, but the question is, what are the compounding periods? And the question says we need to compound quarterly. So we need to know how many quarters are there in 3 years. And in 3 years, if there's 4 each year, it should really be 3 times 4, or there should be 12 quarters in 3 years. Give me a thumbs up if you understand why it has to be a 12. Give me a thumbs down if you don't understand. Okay. So I want you to try and use your calculator technique from today to figure out what the final answer is going to be. You're going to do the first bit, hit equals, and then you times it by the second bit, then hit equals, and you'll get your final answer. And I want to see what everyone gets in the chat. I'm going to do it too, just in case, because so you have to get 5,500 times 1, and then I'm going to hit equals times open bracket 1 plus 0.125 over 4 close bracket to the power of 12, and we get 8831. So 8831.88. Okay. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow that. Just helpful. We're going to do another example of this, but I want to know what speed and what detail I need to go into. You're doing very well here, guys. Like, this is, I know there's a lot of information on the screen. So if you're following this, I don't want you to feel like, oh, it's just run of the mill. Like, I understand I'm pushing you. Okay. Well, then what we're going to do now is you'll see that it's possible to have multiple payments go into the timeline. So let's have a look at this question. So it says, Susan deposited 5,500 into a savings account. 5 years later, she deposited another 4,000. Interest for the first 3 years was 14% per annum compounded semi-annually. Thereafter, the interest rate changed to 12% compounded monthly. How much money does Susan have at the end of 7 years? What's different here is that Susan doesn't just have the amount at the beginning, okay? Susan has the amount at the beginning, sure, and that amount is going to be, I've lost my cursor, where did it go? There we go. So that's the beginning bit. But later on, she adds, and this happens in the real world, right? So like there's the 4,000. Now, all I want you to do is, I want you to ignore the amounts of money for now. Draw a timeline that has the key points on the timeline. I'll talk to you about the 5,500 and the 4,000 in a moment. And it's super easy when you know this trick. But for now, just draw a timeline and then tell me when you're done. You just type done in the chat. But what are the key points in the journey of this money? Some of the money has to travel for a long time. Some of it travels for less time. And T0 kind of seems to come up every time. What would the N be? I suppose it has to be T7 here because in 7 years. What are the other points that are important? Well, the interest rate. We're ignoring the 4,000 for now. T3. I think it's just T3, yeah. So it's just going to be T3. And then I want to know, what is the interest rate from the beginning to T3? And what is the interest rate for the next 4 years? So for this one, let me even just squiggle it here. 0.14 divided by 2. Okay, what's the red one going to be? What's the interest rate for this period? You're going to love this question when I show you the answer. I promise you'll be like, oh my gosh, this is why maths is so beautiful. It just handles it so efficiently. So it changes to 12% divided by 12 because it's monthly. Why isn't it T5 on the timeline? Taryn, very good question. I'm not dealing with the money at this stage. All I'm dealing with is, when does the interest rate change? I will deal with the money in a little bit of time now. But the problem is, if I put too much on the timeline, it gets confusing. And so I leave the money till last. So what I'm going to do here is I'm going to say the money that is at the very beginning is the 5,500. Okay. Now that makes a lot of sense. Now, what you also have is another amount, okay, which it gets added after 5 years. So all I'm going to do now is I'm going to put this point on the timeline, T5, and what I'm going to do is below it, so not at the beginning, but below this new point, I'm going to put plus 4,000. And notice how I don't have them on the same line, because the green has a different journey to the blue. And also notice I only put the T5 here at the end because I wanted to start with just the interest rate. Give me a thumbs up if you understand why this way of writing it shows clearly that the 5,500 has 7 years to journey, whereas the 4,000 only has 2 years to journey. And once students get this, they're like, oh, so we get it. Because you don't group them together. You put them separately to keep them separate. Okay, now we have to finish with this. We know that this is the compound growth formula that we need to use for this question. So what I'm going to do is I'm going to take this and I'm going to solve it, but I'm going to solve it in 2 parts. And I want you to do it with me. So we're going to start with A, and we're just going to deal with the 5,500. 4,000, we'll deal with it later. I want you to draw the 2 brackets. And maybe I should even do it. The 2 brackets here. I'll do this. And then there's going to be another bracket that looks like that. And I want you to try and fill in the values that you think go here and tell me what value you're getting for all those things. Now I'm ignoring the 4,000. I'm not worried about it. So I want you to fill in the missing gaps and then tell me what the 5,500 grows to after 7 years. And look at the timeline. The timeline is your friend. Instead of having to go to the horrible words, which frighten students, they've done the translation phase. So you go back to the timeline. Now, it's half years, but it's half years for 3 years. So this must be 3 times 2 or 6. And that would grow me to the 3rd year, but then I have to grow again. And I can just pull the interest rate off here. And then I ask myself, how many months are there in the 4 years from the 3rd to the 7th year? So it's 4 years times 12, which means this must be 48. So for the red one, there's 48 months that it needs to grow for. For the blue one, it was 6 periods of 6 months, or 6 semi-annuals, basically 6 semi-annuals or half years. 6 half years. So what is the amount that you're getting if you put that all together? You're going to get 13,307.34, but that isn't the whole story. So we're not actually going to completely finish it there. What we're going to do is I'm going to add one last bit. And this bit is going to be 4,000. Now that 4,000 has to grow for a little bit. What interest rate do you think this 4,000 has to grow at? What do you think this 4,000 has to, now again, look at your picture. What's the interest rate I need to use for the 4,000? So Masubulela, the reason we got 48 is if we go from the end of the 3rd year, how long is it from the end of the 3rd year to the end of the 7 years? That's 4 years in total. But in this time period, I want to know how many months there are in this time period, and 12 times 4 gives you 48. Okay, now you're right, because this 4,000 only arrives on the scene in the red interest land, this is going to be that over 12. What is the number at the top here going to be? So how many months does the 4,000 grow for? Okay, so it grows for 24. Yeah. Now, the good news is I'm done. I let the 5,500 grow. And I also let the blue grow, and I've added them together. Now, I want you to get my final answer. The way I do it is I go that times that equals times that equals plus this times this, and you'll get your final answer. Now, remember, you have to do it like an equals here, and then a plus that last bit. And I want to see if you can all get the final correct answer. See if you can get it, and then we're going to call it a day for today. You've done incredibly well, because this has been an interesting lesson, but you seem to have followed, and even if you haven't, I want to encourage you to re-watch this video again. So there is that's the full long working out, in case you're feeling a bit confused. And you should get, oh, is that a mistake? Let's have a look. No, they say, although maybe there was yeah. Is anybody getting the 18 386, yeah. Okay. So that is it for tonight.